Let's do problem 6 from the practice final here. It says a 100 kilogram crate is being dragged up an incline at a constant velocity. The angle of incline is 20 degrees and the coefficient of kinetic friction is 0.3. Draw a free body diagram of the crate. What is the normal force? What is the force of friction? And what must be the magnitude of the applied force? So a lot of work to do for this problem. I'm going to use the procedure here. So let's given. We've got an incline. What was the angle? 20 degrees. And we've got a crate. And it's being dragged up the incline at a constant velocity. So we're pulling it with this applied force. And the velocity equals constant. And you need to know the direction of that constant velocity. It's up the incline, because that tells you the direction of friction. It's going to be opposite of that, right? If you're dragging it up the incline, friction's going to be dragging back for this kind of a problem. And what else do we know? The mass is 100 kilograms. And the coefficient of kinetic friction is 0.3. And what are we trying to find? For A, we want the free body diagram. And here I'm just kind of telling you to do the procedure. What is the normal force? What is the force of friction? And what must the magnitude of the applied force? So we want the applied force. Okay, I'll screen a little bit. There we go. All right. So let me zoom out a bit here. So on the final, setting up the problem like this is worth 1 point. So I want you to do that. Now, for part A, let's draw the free body diagram. I just draw the crate. I don't draw the incline. I just draw the crate. Gravity is always straight down. Now, if you drew little phantom lines like this so you can get at the right angle, that's fine. But don't redraw that. You've drawn it up here. You just want to draw the crate and look at the forces acting on the crate. Here's the normal force, right? This is the, and then we've got this applied force. And then we've got a dragging friction force here. Okay, and that's it. Now, let's make going up the incline positive x and perpendicular to the incline positive y, like that. So that means, now by doing that, the applied force, the normal force, the friction force, they're all lined up with the xy axis, so I don't have to break them up into components. The only force I need to break up into components is the weight. So here's the component of the weight that's perpendicular to the incline, and it's being supported by the incline with the normal force. And here's the component of the weight that's parallel to the incline. And a lot of people want to make this component right here that I'm pointing at, a lot of people want to make that horizontal. It's not horizontal. It's parallel to the incline. So if the incline is diagonal down like this, make that component of the weight diagonal down the incline. Now, the angle of incline, this got rotated 20 degrees. So this is 20 degrees right here. So this is adjacent. This is mg. This force is mg. So that makes this mg cosine theta because it is the adjacent leg. And this is opposite, so it's mg sine theta. So basically what I did there is step 3 of those 5-step procedure. Now I want the normal force. That's what they want in part B. Now the normal force is in the y direction. So I'll just sum the forces in the y direction equals ma in the y direction. And then what are the forces in the y direction? Well, I've got the normal force. And then I have this component of the weight in the negative y direction. And then there is no acceleration in this problem. Well, that means that the normal force is equal to mg cosine theta. So therefore the normal force is equal to the mass times the gravity field times the cosine of the angle of incline. So that's 98 times the cosine of 20. And I get 92.1 newtons. And that's my answer for part B. Now for part C, I want the force of friction. Well, the force of friction is equal to mu times the normal force. Well, the normal mu is 0.3. Hey, big mistake students make, big mistake. They'll on the free body diagram, they'll show the force of friction as being 0.3. Like, oh, the coefficient of friction is the force of friction. No, no, no. The coefficient of friction tells you what fraction of the normal force will be the force of friction. In this case, the force of friction will be 30% as big as the normal force. So times 0.3, I get 27.6 newtons. And then part D, I want the applied force. Well, that's like this, so I need to sum the forces in the x direction equals ma in the x direction. And in the x direction, I've got what I want to find. I got Fa. And then I look at the picture. The free body diagram tells you how to write the equation. So minus the force of friction, minus mg sine theta. Right? I look at the picture. This is in the positive x. This is in the negative x. This is in the negative x. Question?
On part B, I multiplied the normal force by 100 kilograms at 921. You multiplied by 10.
Oh, did I? Oh, thank you. Thank you, thank you, thank you. So this is times 100? Yeah. Okay. Yeah. 900. Yeah, okay. So all I got to do is erase the decimal, huh? And then this gets erased. And this is just 276, right? Is that right now? Yeah. Okay. And if you see me making a little mistake like that, speak up as soon as you can, just so I can fix it. Because if people are watching, I'm not going to redo this, so people watching at home are going to go, wait, and then I finally fix it. But unneeded stress. Okay, so now we can solve for Fa equals, now just put, this is equal to 0, right? Because there's no acceleration in the x. How do I know there's no acceleration in the x direction? Yeah, because it was given. All right, so now what if there is acceleration? You just put it in. You got another term in the equation. So I'm going to add the force of friction. I'm going to add mg sine theta. And now I'm ready to plug in values. Well, I already figured out what the force of friction is, 276 newtons. Plus mg, 100 kilograms, times 9.8 newtons per kilogram, times the sine of 20 degrees. Well, let's figure out what this is. 100 times 9.8, well, that's silly, it's 980, times the sine of 20, which is pretty small. So I get 335. So this is 335 newtons. And I'm going to add that to, and I get 611. Did you all get that when you worked this problem? Those of you who did it? Did I do it right? Okay. So zoom out so you can see the whole thing. Okay, so all of these problems with these force problems, all of these force problems work the same way. There's you need to know how to look at a situation, how to draw the free body diagram, identify X and Y direction. Break up forces into their components based on the angles. Sum the forces in the X direction, that'll give you an equation to solve. Solve the forces in the Y direction, that'll give you an equation. And then you just do algebra to figure out your answer. So none of these steps individually is that hard. It's just that you have to do all of them right to get to the right answer. Okay? All right. Well, that is all.